Our ancestors would envy us. We're healthier, better fed, and more numerous than any generation in the history of humankind. But we exist in an ever-changing world. As our population swells and more of us consume non-renewable natural resources at an unsustainable rate, we must adapt before circumstances force us to. We must move forward. But first, it's important to understand how we got where we are today. In 1798, Thomas Malthus was the first person to meaningfully articulate our fears about population growth. The power of population, he wrote, is indefinitely greater than the power in the earth to produce subsistence for man. Echoing Malthus, global population reached 1 billion in 1804, and it was in this century that the world witnessed an industrial and technological revolution. Yet as technology improved, our capacity to feed a growing population lagged far behind. At the end of the 19th century, Sir William Crookes, the eminent chemist and physicist, told his colleagues that all civilized nations stand in deadly peril of not having enough to eat. It is through the laboratory that starvation may be turned to plenty. A major breakthrough came in 1908, courtesy of Fritz Haber. He devised a way to synthesize ammonia from nitrogen and hydrogen. 5 years later, Haber's inspiration became reality. The Haber-Bosch process created the world's first synthetically produced ammonia. This quickly led to the production of ammonia-based fertilizers. For the first time, fertilizer could be manufactured and developed on an industrial scale. In a short space of time, Haber-Bosch and subsequent developments in ammonia production sparked an unintended consequence, a global population boom. By 1927, there were 2 billion people on the planet. The ammonia industry continued to grow rapidly into the mid-20th century. With this expansion came new safety concerns, mostly triggered by a series of industrial accidents involving low-temperature air separation units. In the late 1950s, the American Institute of Chemical Engineers initiated a series of symposia on safety in air and ammonia plants. In a few short years, the industry overcame most of the safety hazards in air separation plants. The symposia title was changed to Safety in Ammonia Plants and Related Facilities. Then, in the late 1960s, the modern ammonia industry was born. At ICI in Billingham, Kellogg built 3 of the world's first single-stream 1,000-ton per day ammonia plants. At the same time, ICI started to develop the procedures for hazard and operability studies, known as HAZOPs.
One small step for man, one giant leap for mankind.
As man set foot on the moon, population growth back on Earth showed no signs of abating. By 1974, there were 4 billion of us on Earth. In the same year, a serious process safety incident at Flixborough, UK, shocked the chemical industry. The Flixborough disaster prompted the wider chemical industry to adopt ICI's in-house safety procedures. The 1970s and 80s also saw the dawn of the digital revolution. Ammonia manufacturing technology continued to develop as plant capacities increased and efficiencies improved, powered by computerized design and optimization. But by the mid-80s, scientists had discovered a gap in the ozone layer, leading to growing environmental concerns. This resulted in years of debate on how to reduce the size of the ozone hole. A decade later, attendees at the 1997 Kyoto summit tried, and in the estimation of many, failed to make climate change the top international priority. 2 years after Kyoto, world population reached 6 billion. As the new millennium dawned, a new consciousness arose. Green technology and sustainable energy became part of everyday social and political dialogue. Within the ammonia industry, producers were gearing up to meet increased demand while growing ever more efficient. The world's largest and most advanced ammonia plant, Safco 4, was commissioned. Meanwhile, academics, including the late chemistry Nobel laureate Professor Richard E. Smalley, laid out the top 10 problems facing humanity in the first half of the new century, placing energy, water, and food at the top of the list. Technology and politics have made bioethanol and biodiesel a reality to the detriment of our food supply. In 2008, food shortages everywhere from Indonesia to Mexico brought the ethics of using valuable crops as a fuel source into question. To have any hope of feeding current and future generations, we must strike a balance between technological advancement and ecological impact, and it won't be easy. We must find a way to increase food production while reducing our carbon footprint. Striking that balance is made all the more complicated by the need to make money and the pressure to use low-cost feedstocks such as coal. As regulation tightens and natural resources become less abundant, the imperative for the ammonia and fertilizer industries grows clearer by the day to secure our long-term future by becoming more sustainable. Because by 2050, there will be at least 9 billion mouths to feed.